So we have seen three models till now. First one was probabilistic model, another was deterministic model, and third was mixed model. So these were the different types of models. Those were discussed in probabilistic model. So today we are going to discuss first model, that is this one, right? We are going to discuss this first model that is indicated as MM1 is to infinite FCFS. Now what does this include? What does this indicate is first M is used for this A parameter, that is arrival rate follows the Poisson's distribution. Then second M is for uh, service rate or departure rate, that follows the exponential distribution. Then this one stands for what? This one stands for this single facility. We are having only one counter or one facility at the uh, counter, right? Then this infinite is for what? It is the number of customer that can come and get together at the queue. So that is infinite. There is infinite number of customers can come. And last FCFS is for serving order. That is serving pattern. That is FCFS. That is first come first serve. So the first customer that will be arriving to the counter, he will be served first, and likewise in order or in sequence, the other customers will be served. So that is the meaning of all these MM1 infinite FCFS, right? That I have explained. So we'll be seeing that model, and we'll be seeing the formula related with this model, and we'll be calculating the numericals, right? Based on that. So basically, in your syllabus, this MM1, this first model is only there in your syllabus. Actually, there are so many formulas that you can derive for different types of models. Here you can see there are 9 to 10 models available in probabilistic models, right? So in syllabus only there is MM1 infinite FCFS is there. So let us move forward. This was already discussed, that is deterministic model. In that, this was the model 10th model, and last one is mixed model that includes probabilistic and deterministic both in single model, right? That was the mixed model. It is used for complicated examples or complicated problems, right? So let us move with the first model. Here, as you can see on the slide, it is shown that model number 1, that is MM1 infinite FCFS, single server unlimited queue, right? Now here let me explain again that let us consider a single channel queuing system with Poisson arrivals and exponential service time distribution, right? In this sentence only, it is indicating the specification of model. It is a single channel queuing system. Now this is single channel, that you can see that here it is indicated as 1. So that indicates that it is a single channel. There is only one counter, right? Serving facility is only one. And one more thing is Poisson arrivals and exponential service time. Poisson arrivals means what? This M is used for Poisson arrivals, and the second M is used for exponential service or exponential departure, right? Then next is, here we are assuming that arrival rate and service rate are independent of the number of customers in the queue, right? Arrival rate, that is nothing but lambda, and service rate, that is nothing but mu. Those are independent of number of customers. So here the number of customers may go up to infinity. That is already indicated in this nomenclature or in notation, right? And last is, we are assuming that customers are served on the basis of first come first serve. If you are coming first, then you will be served first, right? That is nothing but FCFS. So that is again the meaning of these notations, right? Now here there are some assumptions. Before we solve the numericals, we are assuming something, or in operation research always there are some assumptions, so that it will be better for the calculation, right? In LPP also we have seen some assumptions, right? So here let us see some assumptions. Arrival of customers is following Poisson distribution predominantly, right? It is already assumed that according to this Poisson distribution graph only the customers will arrive. Poisson distribution you can search, right? And you will be seeing a graph something like that, right? Then second is the service time has exponential distribution. That will be e to the power something. That kind of distribution is followed in the service time. Then third assumption is the service discipline is only first come first serve. That is FCFS kind of service distribution is carried out. Then fourth is customer behaves normally. This is also important. Customer behaves normally means what? Here, customer come in the queue, stay in the queue and waits the same queue until the service is rendered. Right? यहाँ पे क्या होता है, कस्टमर क्यू में आता है, कतार में जुड़ता है और अपना नंबर आने तक वही क्यू में, वही कतार में रहता है, इधर से उधर चेंज नहीं करता है अपनी क्यू. राइट, दैट इज द main thing, that customer is behaving very normally. He does not get impatient, right? That is another point. So these were the four assumptions for this model, right? Now, before going to numerical, we need to learn some notations, right? These are following are some notations for this, for the queuing models. So first is lambda, that indicates arrival rate, right? That is number of customers or number of orders per unit time. This you need to keep in mind, that what do you mean by lambda is number of customers or number of orders per unit time, right? So the unit for this will be customers per unit time or orders per unit time, right? It may be possible that we are indicating number of customers or we are indicating number of orders per unit time. Then mu means mean service rate, that is also number of customers or number of orders per unit time, but that is about service. It is about number of customers arriving per unit time, and this mu is number of customers served per unit time, right? यहाँ पे जो कस्टमर आ रहे हैं उसका रेट है पर यूनिट टाइम में, और ये जो है सर्विस, तो कस्टमर और ऑर्डर जो सर्विस हो जाती है उसका रेट है पर यूनिट टाइम में, राइट? Then n is for customers waiting in the system. N number of customers are waiting in the whole system. That indicates the number of customer waiting, right? Then Pn is steady state probability of exactly n customers in the system. P stands for probability, right? So it is the indicating the probability of exactly how much customers or how many customers, exactly n customers, those are in the system. That is the probability of n customers. Then next is ls. Ls is nothing but average length of or number of customers in the system, right? It is nothing but average length of the system or average length of number of customers in the system, right? Then lq is average length of the queue. Q stands for queue, and here S stands for system, right? So this is average length of the queue or average length of number of customers in the queue, and this is average length of the system, that is ls. Then ln means average length of the queue having n customers, average length of the queue having exactly n customers. Then ws, what is ws? That is nothing but expected time customer spends in the system. Ws indicates the time, right? So that is expected time the customer is spending in the system. And wq is expected time the customer waits in the queue, right? W is waiting time, wq is waiting in the queue, and this expected time the customer spends in the whole system, that is ws, right? Then last is traffic intensity, that is rho. This is not p, this is actually rho, right? That is utilization factor, or it is also indicated by lambda by mu. These two are same, right? Lambda by mu. These two are same. Rho is equal to traffic intensity. That is the ratio of arrival rate, that is lambda, to the service rate, that is mu, right? So these are some of the notations. Let us move to next slide. Now here, this traffic intensity indicates that how much time the service facility will be busy. This traffic intensity means which traffic intensity? That is talking about this rho, right? This traffic intensity, that means this rho. What does this rho indicate? This rho indicates that how much time the customer, the service facility will be busy. It indicates the time up to which the service facility will be busy in serving the customer, right? So for remaining time, the facility will idle, right? So the remaining time, the service facility will not be doing any work, it will be ideal, right? Hence the probability of having no customers in the queue is given by P0, right? This is the probability of no customers in the queue, that is P0 is equal to 1 minus lambda by mu, right? That is 1 minus rho. Here I am again explaining. Rho means what? That is nothing but it is indicating how much time the service facility will be busy. So if we subtract that rho from 1, then it will be indicating the probability of having no customer, right? And you know that the total of any probability will be 1 only, right? So that's why we are subtracting this from 1, right? Total of all the probability will be always 1, so we are subtracting this from 1 minus rho, right? So 1 minus rho is the probability of having no customers in the queue, right? Then similarly, based on the mathematical derivations, we can derive probability of n customers in the queue. This derivation you do not need to worry, but you need to learn the formula, right? You need to remember the formula, right? That is probability of n customer is equal to rho raised to n into 1 minus rho. Here this is rho. Don't get confused in P and rho. This is rho, right? That is traffic intensity. So probability of having n customers is equal to rho raised to n into 1 minus rho, right? That is the formula. After that, measures of model. Let us see some more formulas. Now all of these formulas you need to remember, right? All of these formulas you need to remember basically. So then only you will be able to solve the numerical, right? The formula will not be given, right? So let us learn the formula one by one. Length of the system, it is the average number of customers waiting in the queue for getting the service as well as number of customers who are being served at the facility. It is showing this length means that is not some kind of dimension, but this length means it shows the quantity of customer, right? That is having some number. So ls means it is the total number of customers that are already waiting in the queue as well as those who are being served in the facility, right? That is combining both of those customers. That is length of the system, and it is given by ls is equal to lambda upon mu minus lambda, that is equal to rho upon 1 minus rho. That is the formula, right? Then here this is wrong. This I am just, there is some mistake here, that is I am rubbing it. Then length of the queue, it is the average number of customer waiting in the queue for getting the service. This is the quantity of customer or average number of customers those are waiting only in the queue. This does not combine the customers those are being served, right? यहाँ पे वही कस्टमर हमें इंक्लूड करना है जो कस्टमर एक्चुअली क्यू में अपना चांस आने की वेट कर रहे हैं. वो कस्टमर को इंक्लूड नहीं करना है जो ऑलरेडी सर्विस ले रहे हैं, राइट? दैट इज लेंथ ऑफ क्यू. So that formula is ls minus lambda by mu is equal to lambda upon mu minus lambda by mu. So final formula will be lambda square upon mu into mu minus lambda. You need to remember all this formula again. I am telling you, right? So that you will be able to solve the numericals. After that, expected time in the system, that is ws. It can be calculated by the ratio of length of the system to arrival rate. What is expected time in the system? That is the time that is customer is spending in the queue as well as in the service, right? That is the expected time in the system. Ws is equal to, it is indicated by lambda ls by lambda, length of the system divided by lambda. Now length of the system, what is the length of the system? That is lambda upon mu minus lambda. So that will be putting here lambda upon mu minus lambda divided by lambda. So it will be 1 upon mu minus lambda. That will be expected time in the system. This will be in terms of minutes, right? Because it is showing the time. That is ws is equal to 1 upon mu minus lambda, right? After that, let us move forward one more formula, that is expected time in the queue, that is wq. What is this wq? It is equal to expected time in the system minus service time per customer, right? Wq means only it indicates the time that shows only the time that is spent inside the queue, right? That does not include the time that is spent during the service. So that is expected time in the queue, and it is the ratio of, it is equal to expected time in the system minus service time per customer. That will be WQ is equal to, here I have shown the formula. WQ is equal to WS minus 1 upon mu is equal to 1 minus lambda by 1 minus mu 1 by mu minus lambda minus 1 by mu, and that final formula will be rho into 1 by mu minus lambda, or we can say rho by mu minus lambda. That will be the final formula for WQ, that is expected time in the queue, right? That is another formula. Then probability of non-empty queue. This term indicates the probabilities of at least two customers are in the system, one who is being served and one who is next for service, right? Here what does this indicate is at least two customers. नॉन एम्प्टी क्यू मीन्स व्हाट? नॉन एम्प्टी क्यू का मतलब क्या होता है कि क्यू खाली नहीं रहनी चाहिए, तो मिनिमम एक आदमी क्यू में रहना चाहिए। तो एक आदमी क्यू में रहेगा और एक आदमी जो है वो सर्विस लेता हुआ होगा, राइट? सर्विस ले रहा होगा और एक आदमी क्यू में खड़ा रहेगा। तो टोटल देयर विल बी 1 plus 1 means that will be two customers, right? So this probability of non-empty queue indicates probabilities of at least two customer. दो कस्टमर क्यों है? क्योंकि एक कस्टमर क्यू में वेट कर रहा होगा और दूसरा कस्टमर सर्विस ले रहा होगा, right? So that probability of non-empty queue will be given by this formula. You don't need to worry about the derivation. Final will be, this is summation, this is nothing but summation. Sigma means what? Summation n is equal to 0 to infinity pn minus p0 plus p1, that is 1 minus rho plus rho into 1 minus rho. The final answer will be rho square, right? That will be rho square. Non-empty queue, probability of non-empty queue is equal to rho square. After that, average length of the queue for n customer, that is ln. Average length of the queue for n customer, ln is, it shows the length of the queue which is formed continuously from time to time as customer arrives, right? जैसे ही कस्टमर आते जाते हैं और टाइम टू टाइम अपनी क्यू बढ़ती रहती है, तो दैट क्वांटिटी इज शोन बाय ln. It can be calculated by taking the ratio of average length of the queue, that is lq, to the probability of non-empty queue. तो एवरेज लेंथ ऑफ द क्यू, lq का जो फॉर्मूला है, डिवाइडेड बाय प्रोबेबिलिटी ऑफ नॉन एम्प्टी क्यू, जो अभी हमने देखा, दैट इज रो स्क्वायर, एंड ऊपर लैम्बडा स्क्वायर अपॉन न्यू इंटू न्यू माइनस लैम्बडा, राइट? दैट विल बी योर रेशियो फॉर फाइंडिंग आउट एवरेज लेंथ ऑफ द क्यू is equal to mu upon mu minus lambda. Final answer will be mu upon mu minus lambda, that is ln, right? After that, average waiting time in non-empty queue. It is calculated by dividing the average length of the queue for n customers by service rate of facility center. What is this? That is nothing but एवरेज वेटिंग टाइम इन नॉन एम्प्टी क्यू. जब क्यू खाली नहीं रहेगी तब उसमें एवरेज वेटिंग टाइम कितना रहेगा, राइट? उसके लिए फॉर्मूला है WN इज इक्वल टू न्यू अपॉन न्यू माइनस लैम्बडा इनटू 1 by mu, right? That is actually ratio, but we have taken the multiplication because mu upon mu minus lambda divided by mu करोगे तो this will be cancelled, and the final formula will be 1 upon mu minus lambda, that is for WN, right? After that, probability of Q being greater than or equal to any number, say I. Any number means, for example, I number. This is given by I power to the traffic intensity. ये कौन सी probability है? That is Q being greater than or equal to any number, means probability of a Q being greater than, or for example we are getting the number as 2, right? So the probability for getting any greater Q, that will be P greater than or equal to I. For example, here we are putting 2, then it will be rho raised to I, right? This is not P, this is again rho. That will be traffic intensity to the power I, that means for 2, right? Here यहाँ पे दो क्या है, that is length of the queue, right? Means दो कस्टमर खड़े हैं क्यू में, ऐसा है इसका मतलब. Or in general, we can write down I customer. Those are waiting in queue, right? That is the probability I power to the traffic intensity. After that, probability of Q being greater than any number, right? That is given by I plus 1 power to the traffic intensity, right? Here there is one difference. यहाँ पे एक difference है that you can see here, that is only greater than. In previous formula, it was greater than or equal to. You can see here. Here it is greater than or equal to probability, and here only greater than. So if you want to find out probability of Q being only greater than, then you need to use this formula, rho raised to I plus 1 power. For example, here we are putting 2, and here 2 plus 1 is equal to 3. Rho raised to 3. That will be the answer, right? So here it is only greater than, but in previous formula it was greater than or equal to. So if greater than or equal to is there, then you need to put rho raised to rho to the power I. And if you want to find the probability of Q only greater than any number, then it will be rho raised to power I plus 1, right? After that, one more formula is there, average cost due to waiting is equal to ideal time into penalty cost, right? वेटिंग की वजह से जो एवरेज कॉस्ट लगती है वो कितनी रहेगी, पेनल्टी कॉस्ट को मल्टीप्लाई करेंगे आइडियल टाइम के साथ, जितने टाइम जो आइडल रहता है, राइट, अपना काउंटर, उसको पेनल्टी कॉस्ट से मल्टीप्लाई करेंगे. दैट विल बी एवरेज कॉस्ट ड्यू टू वेटिंग. आइडल मीन्स देयर इज नो वर्क बीइंग डन. आइडल का मतलब होता है नो वर्क एक्चुअली बीइंग डन, राइट. After that, probability density function of waiting time in the queue. Generally, this formula is to be integrated for the finding out probability for definite time period, right? You just need to remember this formula. Probability of waiting time greater than or equal to t is equal to rho into mu minus lambda into e to the power minus mu minus lambda into t. न्यूमेरिकल में आपको पूछा जाएगा कि प्रोबेबिलिटी फाइंड कीजिए कि वेटिंग टाइम 5 मिनट से ज्यादा होगा तो, राइट. तो उसके लिए इफ वेटिंग टाइम इज ग्रेटर देन और इक्वल टू 5 मिनट्स, हियर वी कैन राइट लाइक दिस, देन रो इनटू म्यू माइनस लैम्डा इनटू ई इज टू माइनस म्यू माइनस लैम्डा इनटू यहाँ पे टी की जगह पे यहाँ पे हमको रखना पड़ेगा 5 मिनट, राइट. तो दैट विल बी प्रोबेबिलिटी फॉर वेटिंग टाइम ग्रेटर देन और इक्वल टू 5 मिनट्स. यहाँ पे टी की जगह कोई भी टाइम तुमको दिया होगा उसके हिसाब से अपने को कैलकुलेट करना है. आफ्टर दैट, प्रोबेबिलिटी डेंसिटी फंक्शन ऑफ वेटिंग टाइम इन द सिस्टम. देयर इज वन मोर फॉर्मूला. दिस वाज द फॉर्मूला फॉर वेटिंग टाइम इन द क्यू. हियर आल्सो कीप इन माइंड दिस वाज द फॉर्मूला फॉर वेटिंग इन क्यू. ये फॉर्मूला क्यू में वेटिंग करने के लिए था और ये फॉर्मूला सिस्टम में वेटिंग करने के लिए दिया गया है. तो प्रोबेबिलिटी वेटिंग टाइम ग्रेटर देन और इक्वल टू टी इन सिस्टम, दैट विल बी mu minus lambda into e to the power minus mu minus lambda into t, right? So that is for system and this is for q. ये न्यूमेरिकल में हमेशा तुम्हें याद रखना पड़ेगा कि सिस्टम के लिए पूछा गया है या क्यू के लिए पूछा गया है, राइट. तो अकॉर्डिंग टू दैट यू नीड टू remember the formula, right? There will be slight difference in the formula for q and formula for system, right? So these were the formulas. Around 10 to 11 formulas are there that you need to remember, and this is the summary of formula. If you remember this table, then it will be helpful for you to calculate any numerical, right? ये टेबल तुमको किसी भी तरह से याद रखना पड़ेगा because this formula will not be given in exam, right? So by hook or by crook you need to remember these formulas. किसी भी तरह से याद करना पड़ेगा because there will be one numerical in your exam for this queuing theory, right? So these are the formula that we have already discussed. This is length of the system, length of the queue, expected time in the system, expected time in the queue, probability of non-empty queue, average length of queue for n customers, average waiting time in non-empty queue, likewise, right? और सबसे पहले तुम्हें ये पता होना चाहिए कि what is lambda and what is mu. Lambda is nothing but arrival rate, that will be number of customers per unit time those are arriving, and mu is service rate, that is number of customers or number of orders per unit time those are being served per unit time, right? That is lambda and mu. So based on that, let us calculate one example. Based on this formula and all, let us go with one example. Here I hope you can see on the screen, I have shared one example. At barber shop, the customers arrive at the average interval of 6 minutes. क्या दिया हुआ है कि बार्बर शॉप जो है हेयर कटिंग करने की, वहां पे कस्टमर्स आ रहे हैं कितने कितने इंटरवल पे, 6-6 मिनट पे एक कस्टमर आ रहा है एवरेज, राइट? एंड द बार्बर टेक्स ऑन एवरेज 5 minutes फॉर सर्विंग द पर्सन. बार्बर क्या करता है, 5 मिनट में एक पर्सन को सर्व कर देता है. ये बार्बर थोड़ा फास्ट है, इसलिए 5 मिनट में बाल काट देता है सब कस्टमर्स के, एक एक कस्टमर्स के, राइट? सो हियर यू कैन सी दैट दिस इज रिलेटेड विथ अराइवल रेट. ये जो है, राइट, अराइविंग एट द फैसिलिटी, दैट इज रिलेटेड विथ अराइवल रेट, and this is related with the service rate. So this 5 minutes is related with mu. It is not mu actually, but it is related with mu, and this 6 minute is related with what? It is related with lambda, because it is about arriving and this is about servicing, right? Now it is asked that calculate following things. Here there are 7 things you need to calculate: counter utilization level, average number of customers in including at service system, average number of customers in the queue, average waiting time of customers in the system, expected average waiting time in the queue, probability that the barber is idle, barber is not doing any work, and probability of finding the barber is busy, means probably that barber is doing work, right? So these are all things you need to find out. So first of all, we need to start with lambda and mu. Here what will be the values of lambda and mu? For that, let us move to next slide. See here, customers arrive at the time interval of 6 minutes. So lambda is equal to 10 customers per hour. ये कैसे हुआ पता चल रहा है? આ કઈ રીતે થયું કે તમારી ફેસિલિટી છે ત્યાં દર 6 મિનિટે એક કસ્ટમર આવે છે, બરાબર? તો અહીંયા તમારે એક સિમ્પલ કેલ્ક્યુલેશન કરવું પડે, બરાબર? અહીંયા અરાઇવલ રેટ તમારે ફાઇન્ડ કરવો છે પર આવરમાં. ધારો કે બધી વસ્તુ અહીંયા પર આવરમાં થશે, અરાઇવલ રેટ અને સર્વિસ રેટ પર આવરમાં થશે. તો એ તમે કેવી રીતના ફાઇન્ડ કરશો? તો એના માટે 6 મિનિટમાં એક કસ્ટમર છે, તો 60 મિનિટમાં એક આવર થાય, બરાબર? તો 60 મિનિટ્સમાં હાઉ મેની કસ્ટમર્સ આવશે? તો ફોર ધેટ 60 into 1 divided by 6, that will be how much? That will be 10 customers per hour, બરાબર? આ ધ્યાન રાખજો, આ વસ્તુ તમારે પર યુનિટ ટાઈમમાં કેલ્ક્યુલેટ કરવાનું છે. તો અહીંયા પર આવરમાં કેલ્ક્યુલેટ કરીએ છીએ આપણે. તો પાછું સમજાવું કે 6 મિનિટમાં એક કસ્ટમર આવે છે દર 6 મિનિટે, બરાબર? તો ફોર 6 મિનિટ્સ there is one customer. So for 1 hour, the 1 hour એટલે 60 minutes થાય. So for 60 minutes there will be how many customers? So the calculation will be 60 into 1 divided by 6. So that will be 10 customers per hour. So that is nothing but your arrival rate, that is already shown, that is lambda is equal to 10 customers per hour. That is your value of lambda. Then one more thing is that is about customers are served in 5 minutes. In 5 minutes customers are served. So here if you want to find out service rate, in 5 minutes one customer is served, right? So in 60 minutes, that is 1 hour, how many customers will be served? So that will be again 60 into 1 divided by 5. So the answer will be 12, right? Answer will be how much? 12. So 12 customers are serviced per hour. અહીંયા ધ્યાન રાખજો, આપણે પર આવર પર યુનિટ ટાઈમમાં પર આવરમાં આપણે કેલ્ક્યુલેટ કર્યું છે જે સર્વિંગ જે રેટ છે તે અને અરાઇવલ રેટ છે તે. તો અરાઇવલ રેટ જે છે લેમડા તે 10 કસ્ટમર્સ પર આવર, 1 કલાકમાં 10 કસ્ટમર આવે છે, અને મ્યુ જે છે દેટ ઇઝ 12 કસ્ટમર પર આવર સર્વિસ થાય છે, બરાબર. Now you need to find out first thing that is utilization factor. હવે યુટિલાઇઝેશન ફેક્ટરનું બીજું નામ છે ટ્રાફિક ઇન્ટેન્સિટી, અને એને ઇન્ડિકેટ થાય છે રો થી. તો રો ઇઝ ઇક્વલ ટુ લેમડા બાય મ્યુ, બરાબર. આ નામ યાદ રાખજો, યુટિલાઇઝેશન ફેક્ટરને બીજું શું કહેવામાં આવે છે? ટ્રાફિક ઇન્ટેન્સિટી. અને ટ્રાફિક ઇન્ટેન્સિટી એટલે રો, અને રો જે છે દેટ ઇઝ લેમડા બાય મ્યુ. That is lambda is equal to 10, 10 divided by 12, that means 5 divided by 6. That is your utilization factor, બરાબર. એના પછી એવરેજ નંબર ઓફ કસ્ટમર્સ ઇન ધ સિસ્ટમ ઇન્ક્લુડિંગ ધ સર્વિસ કાઉન્ટર, બરાબર. તો એવરેજ નંબર ઓફ કસ્ટમર જે છે દેટ ઇઝ નથિંગ બટ લેન્થ ઓફ ધ સિસ્ટમ, બરાબર. એવરેજ નંબર ઓફ કસ્ટમર્સ ઇન્ક્લુડિંગ ધ સર્વિસ કાઉન્ટર એટલે શું છે કે જે કસ્ટમર છે તે ક્યુમાં વેઇટ કરે છે પ્લસ જે સર્વિસ લઈ રહ્યા છે બંનેનો ઇન્ક્લુડેડ કરેલો જે છે ક્વોન્ટિટી તે ઇન્ડિકેટ થાય છે એલએસ થી, બરાબર. એટલે લેન્થ ઓફ ધ સિસ્ટમ, જે વેઇટ કરે છે તે કસ્ટમર અને જે સર્વિસ લે છે તે બંને કસ્ટમરનું કોમ્બિનેશન જે છે તે ક્વોન્ટિટી આપણે ફાઇન્ડ કરવાની છે. દેટ ઇઝ લેમડા અપોન મ્યુ માઇનસ લેમડા, દેટ ઇઝ 10 ડિવાઇડેડ બાય 12 માઇનસ 10 ઇઝ ઇક્વલ ટુ 5 કસ્ટમર. એટલે કે 5 કસ્ટમર છે તમારા એવરેજ, તમારી સિસ્ટમમાં 5 કસ્ટમર રહેશે જે સર્વિસ લેતા હશે તે પ્લસ જે ક્યુમાં ઊભા હશે તે. એવરેજ નંબર ઓફ કસ્ટમર્સ ઇન ધ લાઇન, લાઇન એટલે શું? ક્યુ. તો એવરેજ નંબર ઓફ કસ્ટમર્સ ઇન ધ ક્યુ દેટ ઇઝ એલ ક્યુ, બરાબર. પાછું કેવું છું, આ લેન્થ જે છે તે ક્વોન્ટિટી બતાવે છે. ઇટ ઇઝ શોઈંગ ધ ક્વોન્ટિટી, નોટ એની કાઇન્ડ ઓફ ડાયમેન્શન. સો એલ ક્યુ નો ફોર્મ્યુલા છે લેમડા સ્ક્વેર ડિવાઇડેડ બાય મ્યુ અપોન મ્યુ માઇનસ લેમડા. લેમડા સ્ક્વેર ડિવાઇડેડ બાય મ્યુ ઇન્ટુ મ્યુ માઇનસ લેમડા, દેટ ઇઝ 10 square upon 12 into 12 minus 10, that will be 4 customers. Means 4 કસ્ટમર જે છે તે તમારા એવરેજ ક્યુમાં વેઇટ કરતા હશે, એવો આનો મતલબ થાય, બરાબર. 4 કસ્ટમર ક્યુમાં વેઇટ કરતા હશે. એવરેજ વેઇટિંગ ટાઈમ ઓફ ધ કસ્ટમર ઇન ધ સિસ્ટમ. વેઇટિંગ ટાઈમ આવે એટલે તમારે ડબલ્યુ ને યાદ કરવાનું, અને ડબલ્યુ સિસ્ટમ માટે છે તો ડબલ્યુ એસ નો ફોર્મ્યુલા યાદ કરવાનો. ડબલ્યુ એસ નો ફોર્મ્યુલા છે 1 upon મ્યુ માઇનસ લેમડા, that is 1 upon 12 minus 10, it is 1 by 2. આ તમારો ટાઈમ આવરમાં આવશે, બરાબર. 1/2 hours એટલે કે 0.5 hours એટલે કેટલું થાય? 30 મિનિટ્સ. ઇટ વિલ બી 30 મિનિટ્સ, બરાબર. આ યાદ રાખજો, 1/2 hours એટલે શું થાય? 30 મિનિટ્સ. તમારું જે છે તે આવરમાં આવશે જવાબ. એના પછી નેક્સ્ટ જોઈએ, એક્સપેક્ટેડ એવરેજ વેઇટિંગ ટાઈમ ઇન ધ ક્યુ. પાછો વેઇટિંગ ટાઈમ છે એટલે ડબલ્યુ ને યાદ કરવાનું, અને ક્યુ ની વાત કરી છે તો ક્યુ ઇઝ ઇક્વલ ટુ રો અપોન મ્યુ માઇનસ લેમડા. તો રો એટલે કેટલો છે? 5/6 upon 12 minus 10, that will be again 25 minutes, બરાબર. તમારે આને કન્વર્ટ કરી શકો મિનિટમાં, અને આવરમાં રાખવું હોય તો આવરમાં બી રાખી શકો, કોઈ ઇશ્યુ નથી, બરાબર. આફ્ટર ધેટ પ્રોબેબિલિટી ધેટ બાર્બર ઇઝ આઇડલ. બાર્બર ઇઝ આઇડલ એટલે શું? પ્રોબેબિલિટી ઓફ હેવિંગ 0 કસ્ટમર્સ. આ ધ્યાન રાખજો, બાર્બર આઇડલ રહી છે એટલે કે કંઈ કામ નથી એની પાસે, એનો મતલબ કે 0 કસ્ટમર છે. તો પ્રોબેબિલિટી ઓફ હેવિંગ 0 કસ્ટમર ઇઝ ઇક્વલ ટુ 1 માઇનસ રો, એટલે 1 માઇનસ 5/6 જે આવેલું દેટ ઇઝ 1 માઇનસ 0.833 ઇઝ ઇક્વલ ટુ 0.167, બરાબર. પ્રોબેબિલિટી ઓફ બાર્બર આઇડલ એટલે કે કંઈ કામ નથી, એટલે કે 0 કસ્ટમર છે ક્યુમાં, દેટ ઇઝ P0. એના પછી પ્રોબેબિલિટી ઓફ ફાઇન્ડિંગ ધ બાર્બર ઇઝ બિઝી. બાર્બર બિઝી છે એની પ્રોબેબિલિટી કેવી આવશે? દેટ ઇઝ આ જો છે તે આઇડલની પ્રોબેબિલિટી છે, બરાબર, કે આટલા ટાઈમ આઇડલ રહી છે. તો બીઝીની કેટલી હશે? તો આને 1 માંથી બાય સબટ્રેક્ટ કરી દેવાનું, તો 1 માઇનસ P0 ઇઝ ઇક્વલ ટુ 1 માઇનસ 0.167 ઇઝ ઇક્વલ ટુ ધીસ વેલ્યુ. અથવા તો તમે ડાયરેક્ટલી લખવું હોય કે પ્રોબેબિલિટી ઓફ ફાઇન્ડિંગ ધ બાર્બર ઇઝ બિઝી ધેટ ઇઝ સેમ એઝ રો. આ યાદ રાખજો, તમારે 1 એકમાંથી બાદ નહીં કરવું હોય તો પાછું એનો એ જ આન્સર આવશે. પ્રોબેબિલિટી ઓફ ફાઇન્ડિંગ ધ બાર્બર ઇઝ બિઝી ધેટ ઇઝ નથિંગ બટ ટ્રાફિક ઇન્ટેન્સિટી, that is nothing but utilization factor, that is nothing but rho. તો તમે રો નો આન્સર ડાયરેક્ટ તમે લખી શકો, બરાબર. આફ્ટર ધેટ ચાન્સીસ ધેટ ધ કસ્ટમર વેઇટ્સ મોર ધેન 30 મિનિટ્સ ઇન ધ સિસ્ટમ, બરાબર. હવે આ પાછું પ્રોબેબિલિટી નો આવ્યું કે કસ્ટમરે વેઇટ કરવું પડશે મોર દેન 30 મિનિટ્સ ઇન ધ સિસ્ટમ. તો આ એનો ફોર્મ્યુલા છે અને અહીંયા ટીની જગ્યાએ તમારે 30 મિનિટ્સ નથી મૂકવાનું, બટ યુ નીડ ટુ પુટ ઇટ ઇન ટર્મ્સ ઓફ આવર્સ. 30 મિનિટને કલાકમાં કેટલું લખાય? તો અડધો કલાક એટલે કે 0.5 આવર, બરાબર. 0.5 તમારે મૂકવું પડશે આવર્સમાં. તો આ ફોર્મ્યુલા તમારે યાદ રાખવો પડશે, બરાબર. It is showing the probability that customer waits more than 30 minutes in the system. Then probability of having more than 3 customers in the system. આ યાદ રાખજો, ખાલી ગ્રેટર દેન 3 છે અહીંયા, ગ્રેટર દેન ઓર ઇક્વલ ટુ નથી, ઓનલી ગ્રેટર દેન 3 છે. એનો મતલબ આપણે ફોર્મ્યુલા યાદ રાખવાનો, રો રેસ ટુ i પ્લસ 1. અહીંયા ખાલી ગ્રેટર દેન ઓર ઇક્વલ ટુ હતે તો અહીંયા રો રેસ ટુ 3 કરતે, બરાબર. પણ અહીંયા ગ્રેટર દેન જ છે, ઓનલી ખાલી મોર દેન 3 જ છે. તો 3 પ્લસ 1 દેટ ઇઝ 0.833 raised to power 4, that will be 0.482, બરાબર. તો આ આખો તમારો ન્યુમેરિકલ થયો જેમાં તમે અલગ અલગ વસ્તુ ફાઇન્ડ કરી અને તમે જોઈ શકો છો, ઇફ યુ અન્ડરસ્ટેન્ડ the data and if you know the formulas, then only you can calculate each and every sum very easily, right? So start remembering these formulas because there will be one or two examples regarding this queuing theory, right?